Hello guys, good afternoon, good morning and good evening. I hope this meets you well. Sorry, today's lecture we'll be talking about C++ program execution model, memory model. So this actually means we're gonna be going through I'll be taking you through how every lines of code is being run by the compiler. So you're gonna understand very vivid, like clear understanding how each program is being run by the compiler. So I hope and I expect you guys to pay more attention to this particular lecture here. So yeah, the next slide here, I prepared a particular slide that actually sorts how our program is being run by the compiler. So yeah, we have, this is our source code, our programs. This is our program, our source file, the code we write in our C++ editor, and then when we compile it by using the compiler, any type of compiler we use, but as long as we know we are using GCC and we are using Cloud and MSVC, that's Microsoft compiler. So let's assume we are using the normal compiler we use, and we run our source file. And it's compiled. It sends to the compiler. So let's assume this is our compiler, and when it sends to our compiler then runs and generates binary for us. And this binary, it is the one that the computer understands, and let's pretend this is our binary file. Binary file is something that is gibberish, not understood by human, like I said. So it is really understood by computer, so I don't think we can just try and understand what that is. It's really hard to understand what that is, except a machine. And in our last lecture, I missed a particular lesson. I actually wanted to use string. I didn't use string, and I am so sorry. So I'll go back again and make my amendment. I am so sorry. So I'm gonna go back to the folder, and I'll open the same folder we did in the last lecture. So I'm gonna open the same folder. Go. Okay. Let me see if this can work. Okay, it work. I drag it. Okay, I don't need you anymore. So fine, and I'm gonna use string, and before we can use string, and that's before we can enter inputs like name or stuff like that, we have to include the library. So we have to include string library. So this is for string, and we know much about string when we go deeper, but now let me just try and give space and try and understand how this works. So yeah, I'm going to be defining these two things here. So yeah, I will enter string, which is name. Sorry, now I'm going to do std string then name, and I'm going to be doing again, let's just enter grade. So yeah, I'm going to be using those initialization. I'm going to be using it here, and what I'm going to do is that I'm going to say std enter your name, and here it's going to be std get line and std and you write name. So this is how you get the input of character, like names, like text or symbol, stuff like that. So this is how you get your string character. So string character, I'll explain more about data type in the next lecture when we get to talk about it. So after I enter name, I'm going to be entering That's for a grade. Enter grade. So grade is normal since it's just integer, so we are actually using a cin. So but this one here actually is for string. So this is how string is being, this is how we enter our string with spaces. We'll explain that once I use this first. So now don't worry, let me just hold on, let's just hold on. Let me run the code for you. And just say 14. So now what I'm expecting now is to enter my inputs. Those input, I will enter this input first, and before I'm gonna be entering this inputs, then I'm gonna be printing it out, then I'm gonna be entering my name and this one here. So now what's gonna happen, I'm gonna view it and show it up in the terminal and see my binary file, see what we have there. So height 1.0, age, let's see. Okay, there's something wrong here. Something is wrong. Notice that I can't even enter my name. It's sending the next data to it. So see, enter your name, and this is enter your name, and the next one you says enter grade, and it sends the without not giving me the permission to enter my name. Something is wrong. This is actually what happened. Whenever you are declaring your CIN after, then you declare this particular one for string, it sends this particular one, create a new line for you. This particular SIN create in the input, it creates a new line in the input. So this particular line of code consumed the line, like consumed the space that is supposed to be used for getting input from the user. I don't think you guys get me, but I'm coming. Let me just bring it again. When I run my code, when I send this code to the compiler and it's complied and it run. So after I print this stuff, even if this one is not there, let's just comment this out. So this is what happened here. This doesn't matter actually. So let's just look what's happened, what's wrong here. That is not giving us the permission to enter the name. If I should run I called my age and I input my age and I declared string again. I declared string here. So this is actually what happened. If you declare stuff like this particular line of code in the input profile, it creates a new line for you. And instead of this to consume the next one, it's the input that is supposed to be there that is consumed itself. Like now, I want to enter my age. Instead of me entering my age, it's this one that go directly to the age and to the name that I supposed to write. Okay, let me just try and make a correction. So this is the part where I actually run this code here. So this particular line of code actually creates this particular lines of code clear buffer, clear every space you have. So everything you have here, this one here actually creates a new line for us. So this particular line of code actually cleared it. I cleared the space that the input left behind for us. Without the input, like if I should just follow the rules like this, it's going to be leaving or giving us a new line space, and instead of this one to go normally to print this one and should allow me to enter input, this one actually go and go inside of this particular input, go inside of the name directly. Instead of me typing my name, it goes to the particular position, that particular area. So by including this particular lines of code, it clears every lines of code we have, like lines of code before this particular line. So if I should run it again, you're going to see something different is going to happen. So so there's no really big deal there, no big deal. You can just copy the lines of code. I will explain about this when we get to this particular stage, and I will really talk more about this particular flow. I'll be talking more about that when we get to this position to know what that means. So now let's just try and understand what we have here. So and so height and then age. So now it's giving us the permission to enter our age. Reason is that I have cleared the lines of space that this particular lines of code create for us, because we have different, on the norms, this particular stuff here takes input of integer, like integer numbers or arithmetic stuff like that. But when we get to this particular stage here, it is string, it is different. So their address it is not the same thing, they are different. So that is why it's actually making or giving it space for us, creating a new space for us. And then we don't want the space, and we only want it to occur in this way. So then what happened is that it creates a new line for us, and this particular code consumed the next code is supposed to get the input user from. So now I'm going to be entering names. Mike. Mike David. So let's assume this is my name. That's not my name. What's my name? Okay, let me just write my name. I'm serious, I'm gonna write my name. Is that even necessary, God? Oh God, that's not necessary. My name, I'm not be sincere with you guys. I'm not inputting my correct data. So my height, I don't know my height. My age, 20, 21. I'm not 21, but let's assume I'm 21. So my name is, this is my name, and my grades. I'm not in grades. I'm not in grade, but let's just enter this particular stuff range. So now our code is clean and clear because we cleared the profile, we cleared the space. We're gonna understand more about this later on, but just try to understand that these particular lines of code create a new space for us, and instead this one consumes is calling. Instead of this one to print directly, it consumes its calling. Here I have enter name and I have my name. Instead of me having this particular lines of code, it consumed this particular one here. This one here consumed this one. This one here, sorry, this one here. This one is supposed to be here, consume what is supposed to be here. So by inputting this one here, I cleared the lines of space, so to be able to have my code input there. And I hope this is not getting you difficult. So moreover, you can actually enter a specific lines of a name. Maybe I want to enter my name, and let's say name. Just I want to enter a single name, so I don't need to input. I don't need this particular one here, this particular get line. I'll just input. Let me just try and get it for you. Yesterday, string and name 2. and I'm gonna go to this particular side here. So yeah, it's gonna permit me to enter just single name, just single name. It's supposed to be under name. So now I'm gonna write so yesterday name 2. This is what's gonna happen. It's gonna, this one here is for entering just a single name without space. But if you use this particular lines of code here, I'm gonna be entering names with spaces. So let me try and clear this code away, and you see yourself. Let me comment it out, and you see yourself. Let's leave it like this, and let's run this code for us, and let's see how it runs. Okay, good. And so okay, age, other name. So if I should enter all, then if I should enter space and type my name, you see it's gonna give you nonsense stuff because I added space to it, and I added this. See, it's just sent all the old data out for me directly. You didn't allow me to enter this particular grid. Instead of this grid I've already input this one here. So this particular line is used to enter just single lines of code for string, just for single name. Let's run it again. Let's clear it, and let's clear the screen and run it again, and let's see. But before we run, let's adjust some things here. So no, I don't need to adjust anything. I'll just run it, and I'll enter just single character name and see how it works. Just single name without space. So you can actually use to enter different kind of word, just text, symbols, or anything like that. So it's not necessarily it has to be name or so. I'm just following my techniques. Okay, so okay, height, okay, age, okay, other name. So let's say me, and let's just say enter. You see, it allows me to enter new age, and I added grade nights, so it's fine. You see, it's clear and fine. So that is about string. That is just the little story about string. So we'll get to know more about string, and this what's more about this particular lines of code here. But just know that if you have your stuff, this particular lines of code, it's gonna give you a problem, like gonna give you a little bit of problem. And to solve this is by actually clearing the space, the inputs left behind for us. It's by clearing the space, the input left behind for us. It's by clearing the new line. It's by clearing the new line. This actually creates a new line for us. So it's by clearing the new line it's left for us. So by clearing it, we actually have access to know or understand this code well. So that's all about. This is for entering for single character and for entering character with spaces. So I hope this is clear to you. And let's leave this and go to PowerPoint. So what I'm actually want to explain in this particular point is that it will generate our binary, and let's check our binary since we are trying to understand how our code gets runs. And let's go back there and let's see our binary. So for the first time here, we look at our binary. So when we click on binary, our binary is telling us this file is not displayed in the text editor because it's either binary or an unseparated text encoding. So now it is this code editor is telling that this file is probably binary. Which is binary? We know it is binary. So it's or I don't want to know or, so I understand what the file is. So now I want to check what is, I want to see what is there. So I click on open, so we can open it with code editor, and let's just check what is in our code. So we see what we found here. This is all called gibberish. So all these text we have here are binary formats, especially this binary. So actually these things we have here are binary, not understand by machine knows exactly what we have here and we don't know. So now this is what I'm trying to tell you about low level language and high level language. If you check out this line of code we have here, at least it has to be 60. But when we check the binary format of the code, we should get to up to 528. So that's our binary. You have to write a lot to the machine to get just simple text answer. So you see how this works. So now this is just binary format, and this is binary. This is the language the computer understands direct and good. I think this is all I want to show you. And if I go back to this place here, so that is how our programs run. It's sent to the compiler, and compiler runs and generate the binary format. So we are using this as example, or yeah, assuming these are binary. So now let's go to the next slide. So good, fine. I want you to listen to this particular point carefully. Here I create this here is our programs area, our source file. So this is the location, like this is the location, like we have it here, example of what we have here. So this is the program, and this is our program area. So we want to understand how our program, every lines of code, how they get complied one by one. So the first one here, what the first one is that it store 25 in the memory of A, in the integer memory. So integer memory, so let's say I copy A here and I bring it down here. So this is the memory address. This is the memory address in the memory. So this is the memory address. So I stored what 25. I stored 25 here. So the compiler does what it's so the compiler what does is that it stores the value of 25 in this particular part here. So this is the memory address. Sorry, this is the memory address of A, and it's the value, the data stored there is 25. And when it goes to the next one, once it does that, the compiler does that, it stored the value to 25, and it goes to the next line and what store 5 in B. It store 5 in B. So now let's make this B. Let's make this B. So I'm gonna make this B. So it runs line by line, line by line. So let's make this B, and we're gonna make this 5. So we're gonna make this 5. So it's stored 25 in memory, integer memory, int memory. So the variable here, I will be explaining more about variable, but not really now. But this name of this particular stuff is just variable. They are actually called variable. Round, they are called variable. So variable, the variable stores, I store 25 in the variable of A, and that is it here, which is the address. This is particular address. We're talking about memory address more later. So now I store the value of 25, and in the next one here I stored B. I store 5 in B. So now A is 25 and B is 5, and it goes to this particular number, this particular one here, which is C. What happens to C? C does not have value. What do you think the compiler is going to do? C does not have any value. I did not input any value in C. I just declared int and C. So what's going to happen here? This is what's going to happen. The compiler is going to store chunks, like chunks of memory, just anyhow memory, anyhow a value in the memory of this particular one, because I didn't give it value. So it can store chunks of memory there. So we'll understand what that means more later. So this chunks it can be any type of data. It can be -10, it can be 5000, it can be 056, it can be anything, because we didn't give it any value. Sometimes it can be 0. So it's just give it random value, or just store value there. or it can stop 0, like I said, 0 any types junks, just know it just stops junks there. And it goes to the next one, which is it prints this particular statement. It prints it to the console here. It prints the first statement to the console. We have it here, and let's make it white so you can see it clearly. And let's show the stuff here. So we're gonna make this thing white. Okay, so it's gonna print this particular stuff to the console. That's the terminal. It's gonna print this to the terminal because we are actually sending to the terminal. It's gonna print it to the terminal. The same thing happens to the next one. We're gonna print it to the terminal. Sorry, I cancelled it. It's gonna print it to the terminal. So when you get to this particular one here, this is a function. So what do you think the compiler is gonna do? What compiler does, I hope you are getting me. Please just try and understand this. I said what the compiler is going to do is that it stores this stuff in the memory. It stores this stuff in the memory. A, this variable here, we declared ints and a. So we give it the value of 25 and it stored it in the memory for us. The data is stored in the memory. So that's why I have this particular diagram here so you can understand clearly. So then it goes, when it's done with this particular stuff, it is done with this done and done state. It's moved to the M2 and store 5 to it. The next one here, B. So it's this variable here, B. It's located in the next one here. It's to run lines by line, so we stored it and follows the route line by line, so it can generate a very fast code for you. So now the next one is going to be B. So it's follow the next line B. So what is in B? So B has the value of 5. It stores 5 in the memory and data. So we have 5. But C does not have anything. C is just junks. Like junks, it's not something that is meaningful. If we should print this out, it can be junks, it can be 0, it can be minus 5,000, it can be anything. We will see that, we get to understand that more when we get to print things. Might not be in this lecture, but you can even try it yourself. Try and run many types, but don't worry. Okay, get worried. You can try and run or print different types of variable. Though I haven't really taught variable, so that's why I said you should not worry about that. And if you think you can just try and do that, you can do that. Try and print this ordinary stuff without giving it value. It will give you junks value. So now here it's junks, it gives you just junks, so we assume it is nothing. So then, or we just put dot there, just represent junks. And the next one is going to send it to the what? To the terminal. So it's going to send it to the terminal. And the next one is going to send it to the terminal because you say you are printing it, print it. And then this particular one we have its function. How does it deal with function? How does the code understand function? This is what is going to happen. When the compiler gets to this particular part here, this is what the compiler is going to do. Oh, fine. In your code, in your particular int main, your main function, this code actually is not declared anyway. So what the compiler is going to do that, it's going to save this particular memory, disk 6 we have here. So let's copy it. So it will copy disk 6 or mark it red. Let's just use something like this. To mark it red, you give it a sign of red sign, like coming. Design should be designed. Okay, so it's going to give it red mark. It's going to mark it red. That's the compiler at the back end. So it's going to mark it red and let's copy it and it's going to store it in the CPU. So it's going to store this particular place here. Store it in the CPU for you. Once it's stored in the CPU, store this location because the compiler wants to go and locate, like find where this particular lines of code, this code, you want to go and locate it. So the compiler doesn't understand this place. It's confused. So you want to go and look for this particular function we have here. So it stores this class in the memory and it's in the CPU. And when it stores this stuff in the CPU, it is not stored near our program here. This particular stuff is not stored. It is like I'm coming. So okay, fine. So like I said, it is stored. It is not stored near our program actually, but this is what the compiler is going to do. It's going to go. Let's say this is the let's say the code is located at 30. We have line this first lines of code, second, third, fourth, fifth, sixth, seventh, eighth, and in the sixth file here we have it here, and where our location, our function is called, which is this add numbers there, it is in the line 30. It's going to take compiler a lot of, it's going to check everything one by one and go till we get to the particular part here. So there is a gap in between this thing. There is a gap in between it, and the gap is going to be like, it takes time, it takes execution time, it exhausts time. Doesn't run faster, because that's not the way you get your code run faster with these simple lines of code. So now, to understand this, it goes to this particular lines which is stored in 30, and what it's going to do is that it's going to check what is in the line. So in our function, when we have it here, we have our function here. So in our function, what we have here, we said int a and int b. So let's go back here. So it's going to do what? Make this particular one here, that's a, and make this particular one b. So, and in the lines of code here we said return a plus b. So now we said it's gonna say a plus b, return a plus b. So it's gonna say return this particular code here, return this parameter, return a plus b. So now this was going to, it's going to save that to the memory, like it said, it's going to save it to the memory and come back to this particular location. Since it has already saved it, it has give it mark red, and it's going to give it black back since it has locate the function and it has done the necessary things. It has find the parameter, and it has find the parameter a and parameter b. Let's just give me something very easy for you to understand. So it has this, let's say this is a function, this is your function. So in the function we have parameter a and parameter b. So it's make this parameter a this one and parameter b this one, and said a return parameter a plus parameter b, which is this one here, a plus b. So when I say return this one, then it goes back to the memory, it goes back to this particular position here, which is stored in the memory. Because if the compiler did not store it in the CPU, it's not going to find it again. So it stored it in this particular location, so it's going to locate the particular position again. So actually the red stuff I took here does no, not really. Okay, just this is just the fine way of the way the compiler sees it. It stores it in the CPU for you. So it stores in the CPU so you can locate the particular space, particular place you declare your function. And what it's going to do is going to make this a plus b. So in a plus b, in here we have a plus b, we have the value of 25 and we have 5. So it's going to make a 25 and it's going to make b 5, and it stored the data we have here. So a 25 plus 5 is going to be 30, and it store it in the value of c. So it stored the data we have here and store it in the value of, it store it in the variable. Here we don't have anything here before, but now we are giving it something. We don't have value in C, but now we are giving it something. It's going to give it 25, and then it's going to go to the next one and print it to the console, and print it to this console, and it's going to print this next one also to the console. So that's 3 sorry. So and it's going to make 4 to the console. So that's the end of our program. So now your actually binary format, when you declare your stuff and when you run your code, it's being stored in your hard disk. Your hard disk. I have actually talked about hard disks in our last lecture. That was the introduction to programming language. I talked about hard disks, what can be stored there. I talked about, of course, you should understand more about hard disks yourself. And or just on a hard disk is just a storage device. So our file is stored in our hard disk in a binary format. And then when the compiler understand, or how does the compiler understand this stuff, is that it's check the code lines by lines, till it gets to the last point here, only from the entrance point of the code, which is the int main. So this way of understanding the hardware is kind of, but let me try and bring this in again. This is this is the memory of the program you have here. So let me see. Okay, sorry, I didn't really formulate this thing very well. I didn't formulate it very well. So now, since it add a plus b and it's going to make it towards 30, so now let's say since it's giving 30 and c is nothing, and it's going to print this one, and when it comes back to c, when it print this one, so it's going to be next one c. So it's going to be, if I'm right, so it's going to store the value of, it's now I'm calling c again, so it's going to store the value of 25. Yeah, 25. Yeah, I said 25. 30, of course, 5 plus so sort of store the value of 30 inside of this particular place. But see the difference between this particular place, this particular code, this 6 and 7, it is not the same way it happens between 4 and 5 or 3 and 4. What happened here is different. It has to jump from 6 to 30. So before the compiler jumps from 6 to 30, it actually takes time, execution time. It runs slow. So this kind of code here can make your code run slow, or when you are executing your code, it's going to run slow. So because your compiler is going to jump to this particular line 30 to make use of your value here. So the difference between here is huge, very huge, like it's very huge. So you should know that if you are declaring function like this, it consumes the execution time. It's consumed the execution time. It consumes a lot of time when you execute codes like that. So instead, you can just use inline function, and we'll be talking about inline function more as we continue. So I won't be taking that in this lecture, so I'll be rounding things up. So I hope you get what I'm trying to do, what this lecture is all about. This one we have execution model and the memory model. At the program is run from the start to the end. Just a very simple program we have created, and we have C++ program execution model. We have our source file here, our source code, which is the C++ code, the editor code that we can have here. This is just an example of what I'm trying to say. And then we have a compiler to run our code, and when we go, it generates a binary format. And example, we assume this is our binary being executed, and then we see our code. And now we want to understand our code. Then we bring up this one. We want to understand what happens in this process. What happened in this process? Then we just bring out this is our programs area. This is our program level, and this is our program's code. So this is where our code is going to be run, starting from number 1 to the last number we have here. So it's going to be starting from the number 1 here. It's going to send the value of 25 and store it in the memory for 5, and the memory of B, which is B here, is going to store 5 in the memory, and C, it is nothing. We didn't store anything there. It's going to store chunks memory, chunks. So it's going to store chunks. So random memory can be there. Random data can be there. It is not predictable. So now in the next one we have print 4. We have print. So what the compiler is going to do is going to print direct to the console, but it won't be for you. It is when you execute the code. It is when you run the code. That's when you see it. So it's going to send it to the compiler and to the terminal, and it's going to send this next one here to the terminal, and this one here, this is confusion. So once it sees this kind of confusion, it saves this particular position to the CPU, which is this one here. Once it saves to the CPU, it looks for this particular function we have here. Then it jumps to, now let's say this, we assume this is the function, this is where the location is, and the location is 30. You know, the location of our, did we use function? Oh, we didn't use function here. We didn't use function here. So we can actually have our function anywhere in our program. We can have it in page 1000. I'm sorry, line 1000. I said page 1000. So we can actually have it in line 1000, like 1000 lines, and it's going to look for it till it gets 1000. So you see, that's a very huge way of declaring stuff there. So it doesn't work together. It doesn't, the time does not work together. So it jumps to this particular 30. So once it jumps to this 30, it looks at what is written there, and then it makes use of the value we have here. We have the parameter list, which is this one, then we have the a, and it's going to use store a, make use of this value here, and makes use of this value here. So what it's going to do is going to do the addition, add the first parameter, and the second one is a and b, then returns the result. So after returning the result, we store the result in this particular position here, and we give it value. Now C has value of 30. So now after that, then it goes to the next one there, it prints to the terminal. The next one prints to the terminal. So that's everything about, for now, that's it about memory model. So that's about memory model. That's how the memory compiles your code. So from the add sticks here being stored, or from the source code here being stored, or convert to binary, stored in our, these are our source code is being stored here, and even the binary is stored there. So because when we run the source code, it generates, it shows the source code and generate the binary. But so now let's just assume this. So we are talking about the binary. So these are a sample of the binary and stored in this. This is an example of binary stored in our hard drive. So that's everything about program, simple program and execution model. So thank you very much. I think I'm exhausted. Okay. I think that's all. So bye, have a nice time and take care. See you in the next lecture. Thank you very much.